In this third video, we are gonna do the image labels based on the ground truth of the BIM model and the point cloud segmentation. So in this video, we will produce object labels. As you can see over here, these points are marked per object, and if they're marked by class, all of the columns will have the same color. And in our folder structure, we actually want to produce the image masks of the classes, the image masks of the objects with their JSONs of their corresponding bounding boxes, and also the imagery that have geolocated information. Now about that information, so if we take a look at a random JPEG, they normally have an XMP or a CSV file together with them that contains the geolocation of that image. For instance, this image over here, 1440 is an image taken on site, and it has this rotation parameter and this specific position. Now, if we know the segmented point cloud that we produced earlier, namely the one that we just produced in the last video in PCD, structure from motion, this label video with the different class labels over here, because we know the relationship between the imagery and the point cloud, we can actually transform those point cloud labels to these image labels that we want. So to make sure, we just check the point cloud really fast. So this is week 22, the structure from motion data set. If I go to the segmentation labels, I see the different classes projected over here. And as a result, we want these types of images where we get the bounding boxes for the different objects and their classes. So as a start, we will first run the script, which is called image label production 2, which is of course in the root folder here at code. It's these scripts are actually for the initial image production. Just like the coarse and fine segmentation, this is a two-step process. So we again fill in the input. So this is week 22. It's a structure from motion. Depending on your folder structure, it will be a little bit different. But the important part is that you input the loss file with the labels. So with the 4 labels attached to it, that you assign the JSON with the specific objects, that you have the class JSON, and that we indicate in which folder we want to export the imagery. Namely, we are going to produce a folder called images undistorted 2, which will have the annotations that we will produce in this first course label production, because afterwards we will have a validation step. So we make these folders, we import the point cloud, we import the imagery with their geolocated information, we import the objects that are coming from our 3D point cloud, we import the classes, and then we build a ray casting scene. This is mainly done based on open 3D data. And we have a small issue that we need to correct. Namely, if we ray trace the point cloud, you will ray trace through the point cloud, because this is not a surface model. It's a rasterized model that you can ray trace through. So instead, we make a voxel mesh that is a surface-based model, and thus will create a dense mask. So that's what we do over here. We create a voxel mesh based on an octree. We of course delete these because these are quite resource intensive, and we colorize it according to the object labels. And then we can take a look at this ray tracing scene from the images. So we create pinhole models from the image locations and project the imagery. So we get these image masks that I just showed you before. They look actually like this, or in a more detailed sense, they look like this. Now, interestingly, we actually save both these object and class masks as NP arrays. That's, of course, this is a rasterized array with the same image width and image height as your original image, and it contains the number of the class or the object. Now, these are quite intensive. In a later stage, we will store them as JPEG formats with 3 channels because they have much better compression than these NP arrays. So in every one of these images, we detect a number of bounding boxes from the 3D bounding boxes that we detected, and we can build a similar JSON as the 3D JSON. So here we see an example of the bounding boxes that are ray traced through this script. And if we produce the results, they will be very similar to the 3D JSON. Now, there is a small difference, namely that here we have in the 3D JSON, we have 3D coordinates and some custom information, but because we want to validate the 2D segmentation and especially the object detection, we store it in a specific format that is unique to the roboflow website. We are going to use roboflow to validate our information, and roboflow requires a specific formatting, and we use the COCO formatting specifically for this purpose. Now, the COCO formatting has 3 stages. First of all, it declares all of the categories. These are the classes that we also define. Now you see these are just going from 0 to the length of the classes, so they are local. Afterwards, we will do a remapping to our own classes. So these are the categories. Next, we have the images. They also have a unique name. For instance, image 8123 has ID 3. So again, afterwards, we will have to do a remapping of the image names to the correct JSON objects. And lastly, we have the objects. So according to image ID 0, we have this specific detection, which is the COCO formatted bounding box of that segmentation. Specifically, we use the bounding box of this segmentation. So the result of the script is actually a folder undistorted2 with all of the images that you exported here and your JSON. Now, we strongly recommend to not produce all the labels at once, because if there is a problem with your 3D segmentation, it will protrude to the 2D segmentation. And because a lot more images are taken from a certain object than there are points, if you make a mistake in the 3D segmentation, you will have to correct a lot of images. So what we strongly propose is in the input, you modify this skip step label. So if you have 500 images, you, for instance, start with a skip of 100. So you get every 100 image. So you get about 5 images that you run through this. You upload to roboflow. You check these 5 first if everything is correct, and only then you can increase the skip size. Note that we haven't taken skip size 1 because there is so much overlap between the imagery that it's not in fact useful to produce labels for every single image. Instead, we will take a reasonable numbers because we are still human and we have to validate every label manually. So we take typically a skip or like a 300 to 400 labeled images of each epoch. So the result is our imagery and a temporary JSON file formatted according to COCO. So in the roboflow workflow, we create a new project, which you call, for instance, week 22B. You declare an annotation group. So we have to declare a public project, and you can select a folder, which obviously is going to be this distorted2 folder, and it will recognize the images and the COCO formatted model. So I will just ignore this just for now and go back to my original data set. I actually want to delete this one. Okay, I will delete it later on. But here I already prepared week 22. I uploaded all the imagery. Be mindful to save it also, otherwise you won't get this tab. Now, obviously, it wants to split it into training, testing, and split. You just take everything into the training set. You don't apply pre-processing. In fact, in this step, you don't do anything just yet because we need to validate the labels. Instead, we're going to go to data set, and we're going to validate every single image. So you click on an image, and you take a look at the bounding boxes that are produced here. For instance, here we have a bounding box for the rebar, or here we have one for the columns, and so forth. Now, if everything is correct, the labels will be already mostly correct. Now, if I'm not happy with some of the labels, and I can of course delete them. For instance, let me go to image 2. If I'm not happy with this rebar, or I want to move this rebar over here, that's fine. Or maybe I will create an additional rebar over here. You can press the Control key to switch to the marking tab. And in this Control key, you mark an additional rebar. On the left-hand side, you see your classes over here. So that is a rebar file. Now note that if you're gonna produce classes, please ensure a cutoff distance for certain classes. For instance, here we see a guardrail, but it is really far away. This is not a useful contribution to the benchmark dataset. So you just press delete twice and it will be removed from the dataset. And you continue through these images. This is actually a much faster procedure than having to draw all the labels manually. So here, for instance, we are missing a piece of rebar. And in fact, this object will not be marked in the point cloud. So we forgot that one. That's unfortunate, but at least we have it in the image-based dataset. Now, if we are happy with our results, we can indeed go on and download the data. So if I go to RoboFlow and I go to week 22, I can continue. I delete this pre-processing steps. I also don't need any augmentation. And then I can create this data set. Now, this will take quite some time, and I will download this information. And the result of this will be, I will go to week 21 because I have done it there already. So in the distorted 2 folder, I will get next to my original COCO annotations, I will download a new file, which is called the annotations COCO. That's of course the modified file with the new labels or the deleted labels. You can also change the class label from class to class. And we need to run a final script to now update our initial JSON to the remapping of the classes and the objects, so the object detection is correct. And for that, we of course use image label restitution 2. So that's the final script here at the root folder over here. And again, we mark our inputs, including the location of the modified JSON file. And we, of course, also import the IFC object. Imagine that you have marked a column. We, of course, want the IFC GUID to be present of that column. So that's why we're going to do another ray tracing of the BIM elements to ensure that if we marked new primary or secondary elements, that the BIM GUID is in fact inside. So we import our imagery again. We import the classes. We import the initial annotations. We import the modified RoboFlow annotations, we import the IFC, and then we start to fuse the information. So the initial detections are matched to the RoboFlow object detections. We can always plot a result just to be sure. Like you can see here, it's obviously correct. I think in this case, we added a lot of elements. We create another raycasting scene, but this time for the IFC elements, and we rematch all of the elements. Also, if you ray trace a new point cloud element, it will take the properties of that class object, because a newly created object in RoboFlow will not have an object ID of its own. It needs to be matched to the actual point cloud. And so we export a final JSON, which we can store here, for instance, at week 22 at, I think, the undistorted imagery. No, where is it located? No. Maybe it's purely at images. It's at images undistorted. So there should be a JSON file here somewhere. It's over here. So these are the annotations corrected. So these will be formatted again to our own format. No, these are according to the COCO format. And have the image ID, the category ID, material ID, object ID, IFC ID, and so forth. So for instance, here we have a wall and it has the correct IFC ID. So those are usable by RoboFlow trainable models or other COCO formatted 2D object detection models. So that's it for the 2D label production.